I'm gonna try and share my screen and make sure everything's good. You guys seeing stuff?
I
Yep.
see your window.
Am I good?
You are there you go. I was gonna say you weren't in presentation mode, but you are now.
All right, sweet. Let's get started then. Okay, so my name is Vincent Ledvina. I am a junior physics major at the University of North Dakota. I've been an Aurorasaurus Ambassador since November of last year. I interned with Aurorasaurus this summer, and today I'm going to be talking to all of you about our project called the North Dakota Dual Aurora Camera, otherwise known as NoDAC. And we are partnering with Live Aurora Network and the University of North Dakota for this project. So let's do it. All right, so here's the outline of the talk. First, I'm going to talk about why Aurora cameras are important and why specifically NoDAC fits that need. Then I'm going to introduce to you all what NoDAC is, and besides just like a general overview of the project, I'm going to provide information on the equipment going into the project, the image data itself, and how it will be used, and the timeline for when this project will be online and totally operational. So after that, I'm going to talk about how NoDAC fits with the mission of Aurorasaurus, other citizen science projects, and how it can set an example for citizen science efforts moving forward. So Aurora cameras by nature provide observational data on auroras, which is really good because it helps validate the satellite data we receive. And that's the same data that we use for, aurora chasing. It's used in real science. It's the data that we get. So it's really good when you're able to validate that data with real observations. And because of that, these optical data give context for what's really happening out in space and sort of shows us what real effects the solar wind is causing on the ground in the form of aurora. And the aurora is a proxy for, geomagnetic activity and other phenomena that are going up, are going on in the, upper atmosphere, ionosphere, and also the magnetosphere. And because Aurora cameras provide real-time views of the aurora, you can immediately draw the connection to citizen science reporting of auroras and Aurorasaurus, but I'm going to get sort of to how that all works later in this presentation. But immediately you can see that having a station on the ground showing you a real-time picture of the aurora is important for citizen science. So far, the current camera network is not really uniformly distributed across the globe. There are big gaps in the mid-latitude regions, especially in the United States. And, ironically, even though the aurora is seen most often at higher latitudes, most aurora chasers actually live in the mid-latitude areas. So it makes sense to have cameras positioned somewhere like in North Dakota, where a lot of people could really benefit from that. There are a lot of aurora cameras positioned like Yellowknife in Alaska, and while that's great, there's thousands, hundreds of thousands of aurora chasers in the US who don't really have an aurora camera they can just tune into and really get an idea of what's going on. And this kind of goes into the potential use cases for the camera, because citizen science discoveries are one of the main benefits of having these cameras. There are new types of aurora being found, it seems, more than ever. We had Steve, now we have dunes and beads. And, especially at mid-latitudes, you see a lot of interesting phenomenon like Steve or dunes that occur sometimes equatorward of the typical auroral oval. So those cameras that are positioned up in Alaska and Yellowknife might not see the Steves as much as we would here down in mid-latitude. So it's important to have cameras to monitor all that. And also, because these cameras take images successively, you get to see the evolution of aurora and also these rare phenomenon. And that evolution, especially of Steve and these beads, is what's really sort of the cutting edge of the research going on right now. And having aurora cameras constantly taking photos means you have an entire time sequence of these Steve events. You can see their birth and death and everything. And that's not really something that we have yet. So there's a lot of really good research potential too. And then obviously aurora chasers benefit from an aurora camera because it gives you an actual idea of what the aurora is doing. You don't actually have to go outside and possibly drive hours away from light pollution or to find clear skies. You can see exactly what's going on, which is really, really powerful. And then finally, This Aurora camera, or I guess Aurora cameras in general, are usually hosted online, and that means it's public facing. And while a lot of Aurora cameras really don't have any educational aspects to them, or it's not necessarily the main focus, uh, there's a really big opportunity to have sort of a educational aspect to the Aurora camera, because auroras are super inspiring, and it gets people asking, what is that? What causes auroras? All that stuff. So that's a possible use case of the Aurora camera, is to educate people as well. So now into NoDAC. So NoDAC is an Aurora camera, and in the name it says dual. So what does dual mean? Well, what that means is we're going to have a north-facing camera, which is going to record the Aurora in video. So that'll be real-time video of the Aurora, which is very unique. And then we'll also have an all-sky camera. And what's great about that is that you'll get a really nice view of the Aurora towards the northern horizon, which is with this camera that's super sensitive. And I'm going to be going into all the specifications for the equipment later. But then you also get an all-sky view, which covers larger storms that might go beyond the field of view of the north-facing camera, but it also provides cloud cover as well, which is really important when you're going out to chase auroras or just doing any type of astrophotography in general. So it's going to be a dual Aurora camera. That's where that name comes from. It's also going to be integrated with Aurorasaurus Citizen Science. I'll be going over that more in detail in a little bit. The data will be open source, so all the images coming off the camera will be stored in an archive online, and anybody can download it. It'll be abiding by the fair use data principles, which is kind of a standard. It'll be a resource for Aurora chasers and scientists. As I kind of mentioned earlier, Aurora cameras are super important for those two groups. And then what's almost most important is that this setup will have really high quality results at a relatively low cost. And I'll be going over that as well. But that's really important to mention. So now going into the equipment. First off, where the cameras will actually be housed will be the Martens Observatory. That's a university-sponsored observatory, about 45 minutes northwest of UND, which is where I am right now. It has really low light pollution. It's Bortle 3 is an overestimate. I mean, the Milky Way looks great from there. I was just out there a couple weeks ago. It's super, super dark, and there's no cities towards the north for hundreds of miles, so it's great for viewing the Aurora. And there's also power and internet on site. So it's kind of an obvious choice to put these cameras, because there's really no hard work you have to do with getting power and internet to the cameras if it's just right there. So as I said before, we have both a north-facing camera and an all-sky camera. Starting with the north-facing camera, we have a Sony a7S Mark II mirrorless camera, and that's going to be paired with a Sony 24mm f1.4 GM lens. And if you look at the middle picture, you can see the camera and the lens there. And this will be recording real-time video of the Aurora, and it'll be facing north. And that's a pretty wide field of view with the 24mm lens. So that'll be giving a really good view of the night sky towards the north. You'll be able to see any Aurora that might crop up. The all-sky camera will be a Canon T6 paired with a Rokinon 8mm f2.8 fisheye lens. So when that's in the enclosure, you can see towards the top right, that lid will close, and then there's a little plastic dome that we're just going to drill a hole for, and then the camera will just rest with the lens facing up. That'll give a complete all-sky view right at the observatory, so that'll be great. And then the enclosures were supplied by Live Aurora Network. They're just off-the-shelf Pelco enclosures, but Live Aurora Network has some special hardware. It's also off-the-shelf, but they've rigged it so that the cameras can be powered and also have data transferred over just a single cable coming out of the enclosure. It's just power over Ethernet, which is great. There's a small computer inside each enclosure with a fan to make sure everything's cool, and it's also waterproof, which is important. I want to emphasize that everything here is consumer off the shelf. That's what COTS stands for, and which means basically anyone can do this. Even the Pelco enclosures and all that. Live Aurora Network has all the schematics for it. And it's really not that hard. It's just a proof of concept, basically, that this can get really good data, and possibly other people could adapt this model as well. And then later down the road, we really want to scientifically calibrate these cameras. They're not made necessarily for science. They're consumer cameras, but they have science potential, and all the files are raw. So it's possible that you can actually quantify like how sensitive the cameras are to Aurora. So we think this calibration technique could be expanded to other cameras that people use for their Aurora cameras, or Aurora camera setups. And then as sort of like the technology expands and really develops and cameras get better, this same calibration use could be adapted to all the new cameras that come out. So all right, so moving on to the image data. So the images coming from the north-facing camera are actually going to be stills of a video. So we're going to be having the north-facing camera and the all-sky camera live streaming to a website, and then the north-facing camera will just take the video directly from the A7S II, and that's 4K 24 frames per second video, and it'll just be putting it right on the live Aurora Network's platform, where they have all of their image streams free for anyone to watch. So that'll be great. It'll be a live view of the Aurora. And you can see on the top right, that's the same, basically the exact same setup we're using. And that, I think that was taken in Iceland. So you can see it's really, really high quality video. And I actually own one of the A7S2s and also the Sony 24mm lens. And I've gotten some really, really good real-time video of Aurora from up here. So, even though we might not get serious coronas and stuff like you would in Alaska or Iceland, you can still capture the very low level stuff with video, which is really insane. So that's the north facing camera. The all sky camera will capture roughly 60-second exposures, and those will be of the entire sky, obviously, and each file is about 18 megapixels. So that'll also be streamed to the same site as well. So image streaming, like I said, it'll be through live Aurora Network. It'll be a 24/7 live broadcast, and they already have tons of cameras set up, so they're well equipped to handle basically just two more streams. What's really interesting is that they actually have a proprietary software called IP Timelapse, which can, based on like a threshold of color, it can actually alert viewers when the Aurora is spotted. So we're planning on using this with the NoDAC. And we were kind of thinking, you could actually integrate this into a Twitter account. So our plan is that once Aurora is detected, NoDAC will tweet a roughly 10-second clip of the event, and then that'll be integrated with Aurorasaurus. And I'll go over that more, obviously, in a little bit. But that was an interesting application of the IP Timelapse software, is that we can get Twitter functionality as well out of the camera. And then lastly, all the data is open source, like I said, and all the images will be uploaded to the cloud, and people can download them and do whatever they want, which is great for Aurora enthusiasts, but also for scientists in case there's some really rare Aurora that happens. We could go back through the images and look at it. So the timeline of the project, it was kind of an idea I had back in like March, and I brought it to Liz and Laura and everybody at Aurorasaurus, and we turned it into a poster at HamSci 2020, which you see at the top right. So that's kind of where like we first sort of defined the goals and everything of the project and what we wanted it to do. And then in summer, we just made sure we had concrete plans. We got we got everything set up. And then in August, we partnered with Live Aurora Network, and they tested the enclosures with cameras that they had. And then in September this month, I received internal funding from UND to purchase all the cameras. I've ordered them, and hopefully by the end of the month, we'll have everything installed at the observatory and operational before AGU, where we plan on making a first light result presentation. So that's the plan. All right, so NoDAC and citizen science. So this is the important thing. Aurorasaurus is really going to take a big role in this project. And, because of the Twitter functionality, it just works perfectly with Aurorasaurus and what we do. We plan on having the actual camera as an icon on the oval map, which you can see at the top right. We'll have like a special icon for it, and then you can actually click on the icon, and then it'll bring you to the image stream. And then when Aurora is spotted, it'll show the 10-second clip as well. So that'll be great. It'll be integrated right into the site. And since we have a partnership with UND, there's also some educational potential. UND has a focus now, is trying to focus more on solar physics, and there's sort of a renewed interest in that. So there's a possibility that the stream could be on the UND website as well, and then maybe integrated into a course or the astronomy club. The north-facing camera has a lot of science benefits as well, a lot of citizen science benefits, because it's recording images at 24 frames per second. Since it's video, it's actually just taking stills really fast, right? And it's been known that Aurora, during really strong events, moves very quickly. And these quick motions, you really can't see with long exposures. Even 1 second, half-second exposures aren't fast enough. And as we've seen before, I mean, just in the little image panel series to the right, one of our ambassadors, Natani, captured some really, really good time sequences of Steve. And that actually got published, and there was real science that came out of that. So that area of auroral physics is still evolving, and it's still really new. And having a video camera trained on Steve would be amazing, because we'd be able to see the really small finger-like green parts and like the picket fence moving really rapidly, and be able to see what's going on there. So really excited for that. The all sky camera is also really, really interesting, because since we're having two views of the aurora at the same time, we're actually able to sort of triangulate the height, or I guess not the height, but you're able to use, triangulation techniques and just basic geometry to derive heights of the aurora. And that's also important for Steve and other rare types of aurora that don't have so many observations yet. So we're able to get really basic parameters just with that simple math. But also, the all-sky camera will be able to monitor cloud cover and also study other all-sky phenomenon like meteors and air glow. And there's other citizen science projects that would benefit from that as well. So those are all future partnerships that we could look at. And then NoDAC kind of represents what I think is the future of auroral citizen science. I think that the consumer off-the-shelf equipment makes NoDAC compatible with a lot of other citizen science efforts, like the Personal Space Weather Station, which was also at HamSci, because especially the all-sky camera, which is super cheap. It's possible to just attach that onto an existing station somewhere that somebody's making, and then if there's plans and schematics for all this stuff, it could just easily be adoptable by other institutions, other schools, other organizations that want to have an Aurora camera near them. And this makes it really, really good for personal projects and anything that is citizen science focused. So I think this is a really good effort that's going to bring a lot of people together. It's going to benefit a lot of communities, and I'm excited for how it's going to be integrated with Aurorasaurus and other citizen science projects. Thank you.
Thank you so much, Vince. Does anybody have any questions for Vince?
Or advice.
Or guidance.
Or advice, yes.
All of the above.
Hey, Vince, this is Don Hampton at University of Alaska.
Hi.
Hey, this looks great. This is going to be a great addition to all this stuff. One quick question: have you thought about your data management?
Yeah. So by that, do you mean how the images will be stored and moved off the cameras, or?
Well, yeah. I mean, have you thought about your data volume, and have you got that covered? I guess it's my
question. Yeah. So Live Aurora Network has a lot of these cameras all over the place. They have a couple in Iceland. They have some in Canada, a bunch in Norway. So they have a cloud storage system that they've been using for a long time. So we're just planning on sort of piggybacking off what they already have basically for that. So I think images will be uploaded over the internet and then stored in the cloud as just an archive. So
Okay, yeah, because the videos are several hundreds of gigabytes per
Yep.
hour. Okay, all right. So
Mhm.
okay, that's great. I mean, I typically we have to deal with our own data up here, and I've got a huge RAID drive that I have my IT team operating all the time. So the other question was for the all sky camera, why are you doing such long exposures?
Yeah, so that's something that we're going to experiment with, obviously, but I think the reasoning behind that is because the actual field of view is so large, you don't have to worry about star trailing. So we're just trying to get the maximum signal out of the image as we can. But we can adjust. So what's nice about the IP time lapse software is that you can adjust all the settings remotely. So you could adjust. I guess the aperture is fixed since it's a manual lens, but you could adjust shutter speed and ISO. So we can change the exposure. I just put in 60 seconds because that was just I was just doing some calculations based on star trailing that would be sort of the maximum at
And is
8 millimeters. So
so that that 60 seconds will now be your basically time based. You take an image every minute. Is that what the other camera systems do, or?
yeah, so a lot of I'm not really sure what the other all sky Aurora cameras do. Some of them do every 15 seconds, some of them do every 30. So we're going to take a look at that, and I guess we'll make adjustments as we need. But
Yeah, I mean,
that's
I typically run every 10 seconds, and
Mhm.
if I can, even run every 5 seconds if
Okay.
possible. Is that for the all sky? That'd be nice to be able to reproduce a time lapse at that kind of rate. So
Right, right.
anyway, so I just think about that a little bit more.
Yep.
Again, with I assume that Canon has pretty good ISO, and so with 12,000 ISO, you can take a pretty short exposure to get Aurora.
Yep. Yep.
Airglow and other things, maybe you may just have to co-add images later on. But anyway,
Right.
but no,
Yeah.
I think that this is really great. It'll be nice to have a expanding array of cameras. In fact, we've got a Sony at Poker Flat we've been running, and I'm going to put one down at Harp, try to catch more Steve events now, and we've got one up at further north as well. So yeah, it'd be
Nice.
nice to expand this whole array of cameras out there. So good job. Thanks.
Thank you.
Thank you, Don. Great comments, definitely, and some things we want to think about more. One thing we've started to think about is the possibility of calibration for this system and ways to do that so that again, probably not to the level that a Cadillac system would be calibrated, but if these two cameras are calibrated to each other and roughly to physical units, then it also allows someone else that's nearby, say like Vincent or someone else with different cameras, to know the sensitivity of their cameras. Or there could be other techniques that we'll use that would be useful for other people to figure out the sensitivity of their cameras, because that's one thing that's constantly changing. Maybe not constantly, but it is evolving. Does that make sense? I think you're muted. Yeah.
I pushed the wrong button.
Yep.
Yeah, I've done a little bit of work on the Sonys that we have. I was mostly worried about timing because I was interested in the video aspect, and I found that I guess one word of caution is when you take the video, you don't actually get raw images anymore. It goes through a codec. So you get, I mean, otherwise the image, the video sizes would be, thousands of gigabytes per night. So, um, but one thing I was curious about is the timing on the video, and so I did some tests in the lab with an LED that popped on and off really quickly, and found that I was worried about just smearing of timing. It turns out it's not too bad at all. In fact, at 30 frames per second, you can't see any kind of smearing in the codec, so that's good. The absolute, I'm pretty convinced the video they do some sort of what they call gamma function, which is it's not, if you double the intensity, you don't double the signal. It actually has a roll off because you've got a wide range you got several orders of magnitude range you want to deal with. I just haven't been able to map out that gamma function yet, so maybe that's something we could work on together at some time.
Yeah, that's interesting.
Other questions? Requests? Very cool what you're planning on. Vincent, we look forward to seeing Aurora, and hopefully we'll have a few storms too.
Yeah, hopefully the new solar cycle is right around the corner.
Thank you so much, Vince.